Okay, so I have a really short time to make a Brainfuck interpreter. So let's begin by opening the terminal. Let's cargo new PF and let's cd into that, and let's open up nvim main.rs. Let's check that everything works. Okay, cool. So this would be pretty easy. Brainfuck only has 8 commands: left, right, plus, minus, output, input, and a loop. So that's cool. So let's start simple by printing a file a line by line. So um, let file let reader actually be buff reader, which new which will take file open and one script dot bf, which is the extension of Brainfuck. This of course wouldn't work because this returns a result. So let's make a main return a result. So result void and a box of dynamic arrow and arrow. That should do it. Okay. So that's okay, and let's add a question mark so we know that will return an error. Okay, so we have our reader. So let's try to go line by line and then print that. For line in reader dot lines, print ln line. Okay, and that should work, but now we actually need to create script.pf, and let's say this is a test. Let's make it happy. Okay, so this works, and now let's try to run it. It works. So now it's time to actually go in each and every line and go character by character and then process it. Okay, we can close that for now and do for okay, let's make line an actual string so we don't have to use an question mark every time. So for c in line, how do you iterate dot characters? Okay, so we can print that. So print, how do you do that? Like that maybe, and then yeah, and that should print everything character by character. Yeah, but let's make it more obvious because it looks exactly the same, and now you can see that it prints everything character by character. So now we can actually start processing the characters, which is pretty exciting. So let's actually add a constant, which will be const arr len, which will be a u size of, let's say, 3000. And we want let mute ptr, which is our actual cell pointer, which will just point at 0 by default. Okay, so that's cool, and we want to actually start doing things. So function process character, which will take a character. I forgot how do you do that? Do it like that, right? I didn't program in Rust for a really long time. Okay, so we do it. We take a char, we take a ptr by mutable reference to i32, and we actually want our array. So let mutable ARR, which will be actually, we want 0 and ARR length. So it will make a slice of 3000 zeros. So we want to take that, or we also want to take that. So ARR will take it by mutable I32 if I'm not mistaken, and we can start doing things. So match C. So we need a default case. And we will, if for when we can't actually process this character, for example, exclamation mark. So let's panic and say arrow could not process character, not process. Let's do it like that, and C, and that should be it. So let's start by adding. We want to add that, and that should be pretty simple. PTR would actually, the value of PTR would be equal to, if I'm not mistaken, it should be a value of PTR plus 1 max of ARR len minus 1, and we should really actually make PTR a U size rather than an I32. So this line will make sure that we won't exceed our array bounds. So we can do the same things for left, but with -1 and a minimum. Oh, this should be a min. This should be max, but with 0. So now we can move left and right, and now let's add a plus and minus to increase and decrease the actual cell. So plus would just be ARR at PTR equals ARR at PTR plus 1. If I'm not mistaken, that should be everything. And we need to actually take the value. And now we can do the same thing for minus, which is pretty simple. So let's add loops, which should be pretty interesting. And the way loops work is that they check if the current cell is equal to 0, and if it is, they skip the loop. If not, they continue. So let's do it like that, and let's open an actual scope. So if ARR at PTR, at the value of PTR, is equal to 0, then we just want to return, because our loop is incapable of running. But if we can run the loop, so if it's different than 0, if it's greater than 0, then we can just go on. But if we don't, we need to actually skip to the next closing bracket. Okay, so that would actually require us to have an I. So I, which will be a mutable U size, because that's the data type in Rust for iterations, and we also need line. So let's change that from just a character to a line, which would be a slice of characters, and that should be a mutable reference. And now we can do just line at PTR. And if that works, then we can just go on. Oh, line at I, actually. So we can do a while loop. Okay, so loop if 9 at I is equal to \n. Then we want to panic, but that's for later. Else if line in this place is actually equal to closing bracket, then we can actually just break. But unless that happens, we can just do I equals to I plus 1. It will just go on until it finds an actual closing bracket, and this wouldn't work. So if I is equal or greater than line length minus 1, then we want to panic because we couldn't find a closing bracket. Panic arrow could not find a closing bracket, so that should jump to the next closing bracket, and if it can't find it, it will panic because that's Rust. Okay, now it's time to do the same thing for the closing bracket, and it should be pretty easy. We just need to reverse things. Let's start by changing the actual char, and if the actual PTR, if the actual cell is equal to 0, now we can just return, unless and if we don't, then we need to jump back to the opening bracket. So if I is, it's way simpler in that orientation. So if it's lesser than 0, we don't even actually have to do this check, because we are working with U sizes, so negative numbers wouldn't work. It will panic on its own. If line is equal to opening bracket, then if we don't, then we need to decrease it by 1. This should be almost everything, so we can check that everything works using a really small script. So let's change that to let Charles be line to Charles mutable. We need to make it mutable, and for and let len for line. So for I in len, then we actually need to process char, and things should be pretty easy. So this is not correct. We need to take chars. We don't even actually have to take it by mutable reference actually. We need to take that by reference, and now we have only one problem, which is how to pass chars. I guess that passing line by reference wouldn't work with it. And that should be everything, but this should work. Okay. So let's try to run a little script with our interpreter. So let's try to print H. So the way you do that is the ASCII representation of H is 72. So, and try to follow me. 8 times plus will make our first cell be 8. Then we move to the right, we open a loop. Oh, we don't move to the right. In the loop, we we move to the right. Then we increase by 9 times and move left. Then move right and we print it out. Oh, did we actually add a print function? No, we didn't. So let's add that real quick. Let's check that out. So let's try to run it. Oh, I'm stupid. Wait, it should have worked. wait, let's try to print the actual array and see if everything worked. Let's make it 10 long because we need to actually print it. Oh, so it did work. I didn't notice it at the beginning, but it also didn't work. Oh, that's right. We forgot to decrease it right here. So we move to the right, we increment it by 1, then we move back. Okay, so it did one loop, but it didn't come back. Okay, why is that? Okay, so now it works. As you can see, we print out H over here. So if you are wondering, the reason it didn't work was because what I was doing before was using a for loop like that. It was okay, but I think because the way for loops work in Rust, it couldn't be dynamic. So changing that to a more manual loop actually fixed everything. So as you can see, we can print out H using the method we showed before. So we should be able to test our interpreter by finding a hello world script from the internet and try to run it. Okay, so after a bit of searching, I found this script which should run hello world. So let's try to run it. And as you can see, we did run hello world. That means we built an actual interpreter of Brainf, and just under 53 lines.